Here we have the integral of cosecant squared x times the square root of cotangent x dx. So we have a product and a composition. We cannot integrate each piece separately, so we are going to try U-substitution. Our U in this case is going to be cotangent x. So we are often looking for an inside function. So cotangent is inside of the square root function. But most importantly, we want it so that the derivative of that inside function is multiplied on the outside somewhere. So the derivative of cotangent, let's start to write it out. If U is cotangent x, the derivative is negative cosecant squared x dx. Now we almost have that. We're just off by a constant multiple, a number, a negative. So we will go ahead and multiply the negative to the other side. So we'll have negative du is equal to cosecant squared x dx. So cosecant squared x dx can get replaced with a negative du. And cotangent x will get replaced with a u. So that's going to leave us with a new integral. That's going to be negative du. So I'm replacing cosecant squared x dx with negative du. And then cotangent x with u. So I'm going to have the square root of u. So we've done a change of variables, and now we have something that we can easily find the antiderivative of. So the square root of u is u to the 1/2. So we'll pull the negative out, the integral of u to the 1/2 du. We will do the power rule here, so we'll have u to the 3/2 times 2/3 plus c. And then we will substitute our u back in, which was cotangent x, leaving us with negative 2/3 cotangent x to the 3/2 plus c. The integral of tangent of 2x dx. So we should take a moment to think about, is there some function that we know of where we take the derivative and we get tangent as an answer? So most people would not consider that a general antiderivative. Some people do memorize the answer to this, which is great, but if you didn't, or if you want to know where that answer is coming from, it's coming from doing a substitution method. But the substitution is not, in this case, 2x. So here, the inside of tangent of 2x is 2x. We're not going to move forward with that as a substitution. What we're going to do instead is rewrite tangent of 2x as a quotient, as sine of 2x over cosine of 2x dx. And so our substitution is going to be to let u be the entire denominator. So again, we're often looking for an inside function. So here, we didn't choose the inside 2x. Here we have a quotient, and we're going to let u be the entire denominator. So u is cosine of 2x. And so again, we know we've picked the right u, or we're on the right track, if when I take the derivative of u, its derivative, or at least its derivative multiplied by a constant multiple, is multiplied in the rest of the problem. So let's take the derivative here. So du is equal to, the derivative of cosine is negative sine, but an extra 2 is going to come out from the chain rule. So negative 2 sine of 2x dx. Well, I have sine of 2x dx, so my du is just off by a constant multiple, just a number. So we'll divide that negative 2 to the other side. So negative 1/2 du is equal to sine of 2x dx. All right, so if we perform our change of variables here, our cosine of 2x will become u, and our sine of 2x dx will become negative 1/2 du. So my integral is going to be the integral of negative 1/2 du over u. So replacing the numerator with negative 1/2 du and the denominator with u. So we can pull out the negative 1/2 negative 1/2 the integral of du over u. Well, that's our special antiderivative, the natural log of the absolute value of u. So negative 1/2 natural log of the absolute value of u plus c. So we will go ahead and plug our u, which was cosine 2x, back in to be left with negative 1/2 natural log of cosine of 2x plus c. So sort of in general, the integral of tangent x dx is negative natural log the absolute value of cosine x plus c. But sometimes you'll also see it written, I'm going to write it down here, as natural log of secant x plus c. So why are those the same thing? Well, we have this property of logs that says if I have a coefficient in front of a log, I can pull it to the exponent here. So this is, in other words, natural log. I'm going to write this as cosine of x to the negative 1 plus c. So bringing this negative 1 to the exponent in here. Well, cosine x to the negative 1, if I rewrite that, it's going to bring the cosine x to the denominator. So it's going to be 1 over cosine x plus c. And 1 over cosine x is secant x. So these are equivalent answers to the integral of tangent x. So negative natural log, absolute value of cosine x plus c, or positive natural log of secant x plus c. So that being said, this final answer over here could also have been 1/2, positive 1/2, natural log of secant of 2x plus c.